Yeah.
Yeah, ma'am.
Hello, yes, ma'am.
Yeah, ma'am. Good morning.
Good morning, ma'am.
Ma'am, may I know from which ID are you logged in to make you as host?
Admin, it's showing
Admin.
like admin. Yes, ma'am.
Yeah, yeah. Okay, ma'am.
Can I start, ma'am?
We have made you as host now. 1 second, ma'am.
Okay.
Welcome back, participants. Now our session is about big data processing, which will be handled by Ms. M. Kartika ma'am from Bannari Amman Institute of Technology. Let's have a quick intro about her. Ms. M. Kartika is currently working as assistant professor in the Department of Computer Science and Engineering, Bannari Amman Institute of Technology, Satyamangalam. She is presently working in machine learning and deep learning projects. She is involved in data science lab. She completed her ME Computer Science Engineering from Congo Engineering College. She holds more than 7 years of professional experience. She published 18 articles in leading national and international journals. She published more than 5 book chapters in leading books of Elsevier and Springer. She is an active researcher in the field of machine learning and data analytics. Also, her research interest includes data mining, image mining, Internet of Things, artificial intelligence, and deep learning. She has filed four national level patents under machine learning and Internet of Things. May we have the pleasure in welcoming Ms. M. Kartika ma'am for taking over the session. Over to you, Kartika ma'am.
Thank you, ma'am. Thank you.
Yeah.
So good morning to all. So first, let me share my screen. So is my screen visible?
Yes, ma'am, it is visible.
Okay, thank you, ma'am.
Yeah.
So guys, today we are going to see, this one of our sessions, we are going to discuss about big data processing. So probably in the previous session, you might have heard about big data and all. So now in this session, I am going to tell you the processing related to Hadoop. So though a lot of big data processing technologies have evolved like Apache Storm, Apache Spark, still Hadoop is used in a lot of companies and a lot of confusions are there with the processing of Hadoop. So I tried to do my best of explaining what Hadoop does. And with a small demo of how a Hadoop has to be installed in Windows and a simple how a simple program has to be executed in Hadoop. So this is my agenda today. So let us start. So first, so big data. So you all have wondered that technologies are evolving day by day. So previously we have used landline phone. Nowadays we are using smartphones. So we have shifted to smartphones. So landline phones, the data gathered from landline phones is nil. But nowadays, how much data is gathered from smartphones? So in smartphones, lot of applications are there, and each and every applications in turn is providing lot of data. And previously we have been using floppy drives, so floppy drives for storing, but nowadays floppy drives have been replaced to hard disks. So because floppy drives capacity, storage capacity is very low and its transfer speed is also very low, we have shifted to hard disks. But exactly today we have shifted from hard disks also. We started storing our data in cloud because we can store large quantities of data in the cloud. So we have shifted our storage from hard disks to cloud also. Then let us see about the various drivers that contribute to the generation of the data. So I have listed two major drivers for contributing to the generation of data, that is IoT and social media. So today in our day-to-day life, we are using lot of IoT devices knowingly or unknowingly. So this data also provides, IoT is a combination of sensors. So each and every sensors in turn will provide huge amount of data. So the total amount of data produced from IoT sensors is also very large. For example, in our house, all are using smart air conditioner. So I hope you all know about the working of smart air conditioner. Smart air conditioner will guesses the temperature of the room, and depending upon the temperature, it will try to adjust the cooling system of the AC. So this is how a smart air conditioner works. So we are using smart air conditioners in our day. So guess how much amount of data smart air conditioner is generating. Then another important driver for the generation of data is social media. See, I have quoted here statistics. So here, according to the social media, uh, when Twitter is concerned, more than 347,222 tweets are produced per day. When YouTube is concerned, more than 300 hours of video are uploaded per day. So we all are using mails. So mails, if for sending and receiving mails per day, we are sending and receiving more than 204 lakh thousand mails, emails. See, these are the popular social media sites we are using. So each day it is generating huge amount of data. So that is called as big data. So big data is nothing but it is a huge amount of data, large volume of data. So the data will be in the form of structured, semi-structured and unstructured. So we cannot tell what kind of data it will be. See, for example, in case of Instagrams, what kind of data will be generated? It will be in the form of pictures or videos. In case of YouTube, what kind of data will be generated? It is completely videos. Whereas in turn of emails, mail processing system, what kind of data will be generated? It is a combination of data. Text will be there, images will be there, and sometimes videos will also be there in our emails. So email is generating three different types
Ma'am,
of data.
Kartika, ma'am.
So yes,
Ma'am,
ma'am.
excuse me. Ma'am, voice is not audible, ma'am.
Voice is not audible.
Yes, ma'am. It's hearing very
Ma'am,
low.
is it audible now? Is it audible now, ma'am?
Yes, ma'am. Yes, ma'am. It is audible now, ma'am.
Okay, ma'am.
Okay.
Okay, ma'am. Thank you. And also big data won't concern with a specific type of data. It is concerned with more than different types of data, like structured, semi-structured and unstructured data. And it is also very difficult to process using our traditional database processing techniques, because the data structure is different, because we won't fix with a particular type of data. It may be a text, it may be like an XML data, it may be a JSON file, or it may be in the form of images, or it may be in the form of video. So we cannot fix it with a type of a data. So that's why big data is involve a combination of data. Now let us see what each and every type of data means. So structured data is a data whose elements are addressable for effective analysis. It can be organized into a formatted repository, that is typically a kind of database. So it concerns all data that can be stored in a database, that is SQL. It will be in the form of a table like rows and columns, and these data will also have relational keys, and it can easily be mapped into pre-designed fields also. So today, these data are most processed in the development and simplest way to manage the information. So example of this structured data is relational data. Then comes to the semi-structured data. So semi-structured data is an information, and this data cannot reside in a relational database, but this can have some organization properties. So by using that properties, we can make it easier to analyze. With some processing, we can store them in a relational database. Okay, so semi-structured data example, very good example for semi-structured data is an XML data. Other examples where semi-structured data is collected is cookies data and JSON data. Then unstructured data is a data which is not organized in a predefined manner, or it won't have any predefined data model and all, and it is also not a good fit for a mainstream relational database. Okay, so for unstructured data, we need to go with alternative platforms for storing and managing. Example for unstructured data is audio, video, images, and metadata. So these is the data involved in big data. So big data as a whole is a combination of structured, unstructured, and semi-structured data. Why big data is prominent? Why big data is prominent means big data can manage and process huge amount of data cost efficiently, and it can also analyze data in all forms, and it captures the data from fast happenings events in real time. It helps to capture the data in real time, and also it handles failures of nodes and tasks assigned to them automatically, and it helps in turning the data into actionable insights. So that's why we say big data is prominent. So examples of big data, we have already seen some examples. So I have told already that more than 400 million, 300 million hours of video are uploaded in YouTube day by day. And Walmart handles more than 1 million customer transaction every hour using big data. And Facebook also handles 40 million photos from its user. Then decoding, human genome decoding. So originally it takes about 10 years of processing, that is 10 years to decode a human genome. But with the usage of big data analytics, we can achieve that decoding process in 1 week. So these are some examples of big data. Then characteristics of big data is, so we all know that 3 V's of big data are there: volume, velocity, and variety. So volume is nothing but it denotes the volume of data that is growing day by day. So experts predicts that the volume of the data in the world will grow to 25 zettabytes in future. See the how much? 25 zettabytes in future, the volume is going to increase. If you take a text file is of about a few kilobytes. A sound file, if you take a sound file, a recording file, it is of few megabytes. Whereas a full-length movie, it is of a few gigabytes. So the data, the sources of data is also added on a continuous basis, and the volume of the data is also growing in a continuous basis. Okay. Then velocity, as far as velocity is concerned, so initially initially companies uses batch processing system to analyze the data. So batch processing system is nothing but if you take a chunk of data, that data will be submitted to a server as a form of a job, and we will wait for the server for the delivery of the result. Okay, so this schemes works properly when the incoming data rate, that is incoming, the rate at which the data comes in, so incoming data rate is slower than the batch processing rate. Okay, and the result is useful despite the delay. But with the new sources of data, nowadays we are using social and mobile applications. So from there, from new processing, new sources of data, we cannot process all this data by batch processing, because the data is now streaming into the server in real time, in a continuous fashion, in a growing manner. And so if we use batch processing system in such kind of data, the result will be obtained in a delayed manner only. So that's why uh, we go with velocity of data. Velocity simply means the speed when the data is generated. Then variety of data is nothing but it a lot of, as we told before, a lot of varieties are there, like structured, unstructured, and semi structured. So the data sources, the variety of data sources also continues to increase. For example, some data may come from internet, that is internet stream. So how many likes are there, and how many of them have commented. So that's all comes under social media and social networking links. Then research data is there, primary research and secondary research data is there. Then location data comes from mobile devices and geospatial data. Then image data is also there. Image data is a video data or satellite image data or surveillance image data. So that's come under the image data. Then supply chain data is there. Then device data is also there. Device data is nothing but the data that comes from the devices, like sensors, PLCs, RF devices. So these are the devices from where data is generated. So that's why we say as variety. So volume, lot, amount is high, and velocity, the speed of incoming data is high. Then variety, huge data sources are involved. So that's why we characterize a big data into 3 V's. So nowadays this 3 V's has become 6 V's. 6 V's. What are the three other V's? Means veracity, variability, and value. Veracity means uncertainty on correctness of data due to ambiguity. So whatever data we are getting, getting as an input, we cannot assure that the data are correct. Okay, so that's why we come with another V called veracity. Then variability means inconsistent data. So while analysis, we will be probably dealing with more number of data, and the data will not be in a particular thing. For example, I will involve a combination of data for providing certain analytics. So for making such analytics, we cannot go with all the data are correct. So there occurs some inconsistencies in the data. That's why another V called variability has come over. Then value is nothing but what business we can generate from that available data. So that is called as value, extracting business insights and revenue from data. That's holds with value. Okay, so these are the three other V's that is involved in our big data: veracity, variability, and value. Then these are some of applications of big data. You all know a lot of applications are there, like aerospace analytics, forecasting, disease analytics, data warehousing, text mining, video surveillance. Wherever field big data is involved, data is generated at a huge manner in there, and all big data is involved. Okay, so these are some applications of big data. Next, data storage and analysis. So storage capacities of hard drives are increasing massively over the years. And with respect to storage capacities, the access speeds of the hard drives is also increasing. Access speed is nothing but the rate at which the data can be read from the drives. So this is also increasing. For example, in around 1990, one typical hard drive could store about 1370 MB of data. Okay, it can store only 1370 MB of data, but it can read all the data from a full drive in around 5 minutes. In 5 minutes, it can read all the data from the full drive. Whereas nowadays, 20 years later, the same hard drive can store about 1 terabyte data normally, but the transfer speed is around 100 Mbps per second. That is, it takes more than 2.5 hours to read all the data of the disk. Though the storage capacity has increased, but the access speeds is also increased. Okay, so the solution is that we need to reduce the time to read from multiple disks. We need to reduce the time of accessing the data. So that is the solution. So let me explain how we can obtain the solution by using big data. So big data and Hadoop. So let us take an example of a restaurant. So to understand what are the problems associated with big data and how Hadoop helps to solve that problem. Okay. So with an example, you can understand clearly how Hadoop is involving for solving the problems involved with big data. Okay. So this is nothing but it is a simple restaurant example. See Bob. Bob is a businessman. Okay, you can take Bob, Ram, anyone. So Bob is a businessman and he has opened a small restaurant. Okay, so initially in his restaurant, he used to receive 2 orders per hour, and he had only one chef with one food shelf in his restaurant. So this food shelf is used for storing the cooked food. From the food shelf, it is delivered to the customers. Okay. So initially, he is receiving only 2 orders per hour, and he had one chef and one food shelf in his restaurant, which is sufficient enough to handle all the orders. Okay, initially. So now let us compare this restaurant example with our traditional scenario where data was getting generated at a steady rate, and our traditional processing system like RDBMS, Relational Database Management System. So this is capable enough to handle just like our Bob's Chef. Okay, here we can relate the data storage, that is our RDBMS system, with our food shelf and the traditional processing unit with the chef. Okay, now Bob thought of expanding his business. He thought of expanding his business, and therefore he started taking online orders. Because of this transition, the rate at which they were receiving orders rose to an alarming figure of 10 orders per hour, and it became quite difficult for a single cook to cope up with the current situation. So similarly, in big data scenario also, the data started getting generated at an alarming rate because of the introduction of various data growth drivers such as social media and smartphones, etc. So now the traditional system, just like the cook in Bob's restaurant, was not sufficient enough to handle this sudden change. Okay. So after a lot of research, Bob came up with a solution where he hired four more chefs to tackle the huge rate of orders being received. So everything was going quite well, but this solution led to one more problem. Since 4 chefs were sharing the same food shelf, the very food shelf was becoming the bottleneck of the whole process. Hence, the solution was not that efficient as Bob thought. Okay. Similarly, to tackle the problem of processing huge data sets, multiple processing units were installed so as to process the data in parallel, just like Bob hired 4 chefs. But even in this case, bringing multiple processing units was not an effective solution because the centralized storage unit becomes the bottleneck. Okay. In other words, the performance of the whole system is driven by the performance of the central storage unit. Therefore, the moment our central storage goes down, the whole system gets compromised. So what to do? So Bob came up with another efficient solution. Okay. So he divided all the chefs into 2 hierarchies. That is, a junior chef will be there and a head chef will be there. Okay. So a junior and a head chef. So and assigned each junior chef with a food shelf. So each junior chef is assigned with a food shelf. Let us assume that the device to be made now is meat sauce. Okay. So now according to Bob's plan, one junior chef will prepare meat and the other junior chef will prepare the sauce. Moving ahead, they will transfer both meat and sauce to the head chef. Okay, where the head chef will prepare the meat and meat sauce after combining both the ingredients, which then will be delivered as the final order. Okay, so Hadoop functions in a similar fashion as Bob's restaurant. As the food shelf is distributed in Bob's restaurant, similarly in Hadoop, the data is stored in a distributed fashion with replications to provide fault tolerance.
Okay. For parallel processing, first the data is processed by the slaves where it is stored for some intermediate results. It is processed by slaves where slaves are responsible for storing what? For intermediate results. And those intermediate results are merged by the master node to send the final result. So this is how a Hadoop works. Okay. So I hope that you might have understand the example of Hadoop working with our Bob's restaurant example. Now let us see the challenges with big data. The three major challenges with big data is that storing the colossal amount of data, that is storing huge data in a traditional system, is not possible. Then storing heterogeneous data, the data is not only huge, but it is also present in various formats, that is structured, semi-structured and unstructured format. The system must store different types of data that is generated from different sources. Next, processing speed. The time taken to process this huge amount of data is quite high as the data to be processed is too large. Okay. To solve the storage issues and processing issue, two core components were created in Hadoop, that is HDFS and Yarn. Okay. HDFS solves the storage issue as it stores the data in a distributed fashion and it is really scalable. Yarn helps to solve the processing issue by reducing the processing time drastically. Okay. So these are the two core components that were created by Hadoop. Now, let us come to the proper definition of Hadoop. Hadoop is nothing but it is an open source software framework used for storing and processing big data in a distributed manner on large clusters of commodity hardware. We are distributing the data into clusters of computers. And Hadoop is licensed under Apache v2 license, and it is also a flexible and highly available architecture for large scale computation and data processing on a network of commodity hardware. See, consider that if we want to paint a room, so the room consists of totally 5 walls. So 4 surrounding walls and 1 ceiling. If we allocate 1 man for painting this room, it will take about 1 day to complete the painting of this room. Instead of appointing 1 man, if we appoint 5 man, 5 man means the complete painting work will be completed in a hour. So the time is reduced from 1 day to 1 hour if we appoint more number of painters. Okay. Let us take another example. See here, I am having an input file that is 10,000 data are there, 10,000 numbers are there. So I need to find the total of all the numbers. So the size of my input file is 1 GB. So if I want to process this file in a single computer, the time taken will be about 50 seconds. So I need to reduce the time. So for that, what I'm going to do means, instead of doing the processing in a single computer, I'm going to do the processing in 2 computers. So first 6,000 numbers will be assigned to the first computer, and the second 4,000 numbers will be assigned to the second computer. So, but the total is total sum is the same from the 2 processing units. Whereas if we use 2 computers instead of 1 computer, the time taken will be reduced from 60 seconds to 30 seconds. So this is the power of parallel processing. So Hadoop actually implements parallel processing. Next, coming to supercomputers. So supercomputers is majorly used in the companies like IBM, Fujitsu, Cray, and Intel and all. So supercomputers are used in weather forecasting, in NASA, and seismic data analysis, and it is also used in university research labs for studies related to bioinformatics and all, and it is also used in Department of Defense for nuclear research. A lot of applications are there with supercomputers, but challenges are there with supercomputers. Supercomputers also work with parallel processing. But the challenges with supercomputers are there. A general process purpose operating system like framework for parallel computing should be there. Okay, we need a general purpose operating system like framework for parallel computing. So if exist some kind of, if such kind of operating system exists, it has to be customized according to our requirement, according to our application. That supercomputers has to be customized. Next, companies procuring supercomputers have to depend upon some specific vendors for hardware support. So they need to depend upon some specific vendors. And also the initial cost of the initialization of supercomputers is very much high. And we need to develop a custom software for individual use cases. For individual use cases, we need to develop software. And the cost for maintenance and upgrades of the software is also very high, which had to be taken care in-house, the organizations using a supercomputer. That has to be taken by the organization, those are using supercomputers. And also it is not simple to scale horizontally. So these are the challenges associated with supercomputer. Now, how Hadoop comes to the rescue of this supercomputers? So supercomputers also do the same work of parallel processing, but these are some of the challenges associated with supercomputers. Now, how Hadoop comes to the rescue is Hadoop comes with a general processing operating system like framework for parallel computing needs. So that is a drawback there in supercomputers. Now, if an operating system exists, we need to do some customization. But whereas in Hadoop, there is no need of doing customization and all. And also, cost of initialization, upgradation is very high in case of supercomputers, whereas Hadoop is a free software, it is an open source software, and upgrade is also very free. And it has the options of upgrading the software at a free cost. And it opens up the power of distributed computing to a wider set of audience. And mid-sized organizations also need not be locked to specific vendors for hardware support. So Hadoop works on commodity hardware. So we it's not necessary to rely on any specific vendors. And the software challenges of the organization having to write proprietary softwares is no longer the case. It's not needed to write any proprietary softwares for specific use cases and all. Okay, so that's why Hadoop is more for better than the supercomputers. Then how this Hadoop has developed? Okay, so in late 90s to early 2000s, so this was the age of internet boom. We all know this was the age of internet boom. So the need of the hour was a scalable web search engine that is needed at those days. So major players in this business of internet search engines where Yahoo like this. Those days search engines are like a file. Okay, we have to download it and we have to install it. So nowadays search engines are embedded in browser, but at those days search engines are like a file we need to download and install. So as like internet have developed, let us see how a Hadoop has been evolved from internet search engines. So the need of the hover for scalable search engine for the growing internet. We need a scalable search engine. That was a big question those days. So internet achieved search director dog cutting. So dog cutting and a graduate student from University of Washington, Mike J. Cafrella. So they set out to build a search engine, and the project named was Nudge in the year 2001 to 2002. And also Google's distributed file system paper came out in 2003, and first file map reduce paper came out in 2004. So in 2006, dog cutting joined Yahoo and created an open source framework called Hadoop. Okay, so the name of the Hadoop came from the name of his son's toy elephant. So he has a son and he has a toy elephant. So from inspiring about of that picture of an elephant, he has named it as an Hadoop. Hadoop tracks back its route to Nudge, Google distributed file system, and MapReduce processing engine. So it went to become a full-fledged Apache project, and a stable version of Hadoop was used in the year 2008 by Yahoo. Okay. So this is the evaluation of Hadoop. Now let us take some of the solutions provided by Hadoop to the problems of big data. So we know the first problem is storing huge amount of data. How Hadoop helps to store huge amount of data means, so usually Hadoop have a file system in the name Hadoop distributed file system, HDFS. So this HDFS will provide a distributed way to store the big data. So consider that your data will be in Hadoop. Your data will be stored in blocks in data nodes, and you need to specify the size of each block. Okay, so if suppose you have 512 MB of data, and you have configured your HDFS such that it will create 128 MB of data blocks. Now HDFS will divide the 4 blocks, that is totally how much amount of data we are having, 512 MB of data. So 512 divided by 128 is equal to 4. So our data is splitted into 4 blocks, and it is stored across in different data nodes. While storing these data blocks into data nodes are replicated on different data nodes to provide fault tolerance. Okay, we are replicating the data also. Replication is nothing but maintaining the copy of the same data in different machine. And also Hadoop follows horizontal scaling instead of vertical scaling. In horizontal scaling is nothing but you can add new nodes to our Hadoop HDFS cluster on the run as per the requirement, instead of increasing the hardware stack present in each node. Instead of increasing the hardware, we can add the new node itself. That is mean by horizontal scaling, and Hadoop follows horizontal scaling. Next problem is how we can store variety of data in Hadoop. In HDFS, you can store all kind of data, whether it is structured, semi-structured or unstructured, we can store. In HDFS, there is no pre-dumping schema validation. There is no any schema validation and all. While in case of RDMS, while designing or while storing a data, first we need to create a schema, and all the data will be stored by following that schema only. Whereas in Hadoop, there is no predefined schema validation and all. And Hadoop also follows write once, read many models. Okay, so due to this, you can just write any kind of data at once, and you can read it multiple times for finding insights in that data. So that is the biggest advantage of Hadoop. So the next challenge is how Hadoop is processing the data faster, how it helps in processing the data faster. So in order to solve this, we move the processing unit to data instead of moving data to the processing unit. Normally what we will do, we will move the data to the processing unit only. Whereas in Hadoop, we move the processing unit to data. We process the data near to the place where data is stored. Okay. So it means that instead of moving data from different nodes to a single master node for processing, the processing logic is sent to the nodes where data is stored, so that each node can process a part of the data in parallel. Finally, all the intermediate output produced by each node is merged together, and the final response is sent back to the client. Okay, so some sort of processing is done locally, and the intermediate results are collected, then it is finally given to the client. So this is how uh, Hadoop helps in processing the data faster. So these are the biggest solutions provided by Hadoop for the challenges associated with big data. Next features. The Hadoop features are reliable, economical, scalable, and flexible. So Hadoop is reliable because when machines are working as a single unit, if one of the machine fails, another machine will take over the responsibility and work in a reliable and fault tolerant fashion. So that's why Hadoop infrastructure has inbuilt fault tolerance features, and hence Hadoop is highly reliable. Then economical. Economical means Hadoop uses commodity hardware. Commodity hardware is nothing but like our PC and laptop. For example, in a small Hadoop cluster, all your data node can have normal configuration like 8 to 16 GB RAM with 5 to 10 TB hard disk, and Xeon processors is enough. So this is of a small Hadoop cluster. But if I would have used hardware based RAID with Oracle and all for the same purpose, I would end up spending 5x times more at least, isn't it? We need to spend a lot of cost for that. So the cost of ownership of a Hadoop based project is minimized. And also, it is easier to maintain a Hadoop environment and is economical as well. Also, Hadoop is open source software and hence there is no licensing cost. That's why we say Hadoop is more economical. Then scalability. Hadoop has inbuilt capability of integrating seamlessly with cloud-based services. So when Hadoop are installed on a cloud, we no need to worry about the scalability factor, as simply we can go ahead and procure more hardware and expand the setup within minutes whenever required. That's why we say Hadoop is more scalable. Then flexibility. Hadoop is very flexible in terms of the ability it is involved in dealing all kinds of data. That's why we say Hadoop is more flexible. So these are the four important features of our Hadoop. Okay. Then the versions available is Hadoop 1.0, Hadoop 2.0, and Hadoop 3.0. Among the three versions, Hadoop 2.0 is the more stable version because it is introduced. It is a version where Yarn is introduced. Okay. Now let us see the architecture of Hadoop. Hadoop follows master-slave architecture like our Bob's Restaurant example. In our Bob's Restaurant example, how the orders are handled, it is handled by a junior chef and a master chef. Junior chef will prepare some stuffs and they will hand it over to the master chef. Master chef will combine all the ingredients from junior chef and they will deliver the result. Similarly, in Hadoop also we are having a master-slave architecture. So slaves are nothing but the data nodes. Data nodes are called as slaves. So slaves will do all the processing. Slaves will serve read and write requests from the file system clients. Along with it perform creation of a block, deleting a block, and replication of copies of data across different slaves upon the instruction from the master. And also task tracker is available in slave. Task tracker, which helps to execute tasks upon instruction from the master node. Okay, so in the master node we are having three types of nodes like name node, secondary node, and job tracker. So job tracker helps to handle the data motion, that is how the data has to be processed in slaves. And name node, it helps to maintain the metadata information. And secondary name node is a backup for name node. Okay. Then master node, in the master node we are having three types of nodes, right? So the job tracker of master node is the point of interaction between the users and the map reduce framework in slave. Okay, when a map or reduced job is submitted, let us see what is mean by map or reduced job in further slides. So when a job or map reduced job when a map or reduced job is submitted, job tracker, what it do means it put it in a queue of pending jobs and execute them on a FIFO basis, first come first serve basis, and then manages the assignment of map and reduce tasks to task trackers. So task trackers are available where? It is available in slave nodes. Okay, so job tracker is available in master node, task tracker is available in slave nodes, that is data nodes. Okay, so task tracker will intimate the data node to complete the processing, and after completing the processing, the task tracker will communicate to its master, that is to its job tracker, about the status of the job. Okay, this is the architecture how a master and a slave node works in Hadoop. And Hadoop deployment modes. So Hadoop usually comes with 3 configuration modes when it is implemented on our commodity hardware. One is standalone mode, pseudo distributed mode, and fully distributed mode. So standalone mode, it will run locally on a single machine on a single JVM. Okay, then it is not used nowadays. But pseudo distributed mode, here all the services run on the same machine but on a different JVM, and this is used for education purpose, and it is also used in development and testing purpose. That is mostly it is used for education. Then fully distributed mode, here each service runs on a separate hardware. We will have a separate dedicated server for each and every service, and it is usually used in industries, production setup. Okay, so service, we are always talking about service. Service is nothing but it refers to name node, secondary node, job tracker, data nodes. So the process done is by each and every nodes here refers the services. So these are the general deployment modes of Hadoop, 3 deployment modes of Hadoop. Next, let us see the functionality of each component of a Hadoop. So name node is like a central file system manager. Okay, it have the metadata information, that is where each and every blocks of data is stored, in which data node handles which data. So likewise, all the file system management is done by our name node. And if the name node fails, we need something to manage the information, because it is like a content page of our book. Name node is like a content page of our book. So it have all the contents, that is where each and every content is located. Okay, so if we turn off the content page, it is like a simple book. If I want to search something, means I have to go through all the book in order to fetch a particular information. So in order to overcome this, a secondary name node has been introduced. So secondary name node is like a backup for our name node. So it will maintain all the information that is stored in the name node. Okay, so it is like a backup node. And job tracker is a job scheduler. It is a centralized job scheduler. It helps in scheduling the jobs. Okay, so these are the 3 important nodes available with master nodes. Then slave nodes or daemons. So in slave nodes, we have 2 types of nodes called data nodes and task tracker. So data node from the name indicates, we can guess that here is the place where data is actually stored and data is actually processed. So this is the place where actually data is processed. And task tracker is nothing but it is a service. It is a software service which monitors the state of a job tracker. That is, each and every data node will have a task tracker, and it helps in monitoring what is happening inside the data node. Okay, then after some minutes, in default after 3 seconds, each slave node, each task tracker will send a heartbeat signal. Heartbeat signal means it will send an information to their master node, to the name node, that it is alive. Okay, what is happening in the data node, all information will be sent to the master node every 3 seconds. Okay, slaves will usually have powerful configuration than our master node, because master node is just doing the supervising job, whereas slave nodes only actually doing the processing. Okay, that's why the configuration of slave nodes would be more than the masters. Then job, what is a job in a Hadoop? Job is nothing but it is a task that is given by our user, that is called as job. A job will be in the form of a program, or it will be in the form of a collection of programs, and this program need to be executed. A job will always have some properties, like it will be the actual program, and it will contain the input data to the program, and also it should contain an output directory. Output directory is the place where output results are stored. So a job will have these properties. Okay, so job is nothing but an input that is provided to our Hadoop system. How a job is submitted and executed in a Hadoop cluster. So this is how the user, or we call them as an engineer or analyst. Okay, so the analyst machine is not a part of a Hadoop cluster. This is separate. Analyst machine is separate. It is not a part of Hadoop cluster. So usually Hadoop will be installed in a pseudo distributed mode on her machine. So the programs, the job would be submitted to the gateway machine. So the gateway machine will do the necessary configuration to communicate to the name node and job tracker. Okay, job gets submitted to the name node and job tracker is responsible for scheduling and executing the job on the data nodes in the cluster. Okay, so this is how a job is submitted and executed in a Hadoop cluster. After performing the processing, the result will be communicated to the name node, and the name node will send information to the analyst that the job has been completed. Okay, so this is how a job will be executed in a Hadoop cluster. So the prerequisites of understanding the Hadoop distributed file system is we need to understand what a file system means. Okay, and we need some practical knowledge of Unix file system basics to work with Hadoop. Okay. Now let us take an example of how a Hadoop distributed file system actually stores the data. Okay. Consider that our input file is of 200 MB. It is in the name new file.txt. Okay. So the format of our file is a text file. So in this file, we have a line of integers and the integers are separated by spaces. This is the format of our text file. Okay. So this is the file input that is provided by the client to a Hadoop system. So where that input file goes, input file first for storing this data, the client will communicate to the name node of the cluster. We have seen, no? So first the client will communicate through the gateway. It will communicate to the name node. Name node will check the availability of the data nodes, which data nodes are free. It will check the availability and it will send information to the client that these nodes, these data nodes are available. Okay. And what client will do means client will store the data in those name nodes that is provided by the in those data nodes that is provided by the name node, and the name node in turn remembers which part of the data is stored in which part of the data nodes. So this information is remembered by the name node by means of an FS image. FS image is nothing but file system image. Okay. So FS image is maintained by our name node. So that FS image provides us the information about where each block of data is stored. Okay. So consider that we have splitted our data nodes. We are having some 12 data nodes in our cluster. Data nodes is nothing but the normal system. Okay, we are having some 12 systems in our cluster, and each and every system have a size of about 64 MB. Okay, consider it's for an example, but originally it's not equal to 64 MB. Consider that it is equal to 64 MB. But the input file size is 200 MB. The input file is about 200 MB, right? So we need to split this 200 MB because each data node can hold only up to 64 MB alone. So we are going to split this 200 MB. How we are going to split means simply we are going to subtract this total number of MB with our 6 with just a minute. And it gets splitted into 4 blocks, N1 64 MB, N2 64 MB, N3 64 MB, and the remaining 8 MB will be that 8 MB will be stored in N4. Okay, so these are the names of our blocks. So our 200 MB file is splitted into 4 blocks according to the size of our data node. The first block is N1, second block is N2, and third block is N3, and next block is N4. Now, after splitting the data into blocks, client communicates with the data node. Sorry, with the name node. The name node, actually this breaking of our file into multiple blocks will be done where it is done in the client machine itself. After communicating the name node will provide the information of where to save the data, in which data nodes we need to save. Consider that client has given the details like store the data in DN2, data node 2, data node 5, data node 7, and data node 10. It passes the information to the client machine. The client machine will directly writes the file to the data node once the name node provides the details about the data node. After getting the details from the name node, client machine starts writing the data directly into the name nodes. That is into the data nodes 2, data node 5, data node 7, and data node 10. This is how a data will be stored in the data nodes using Hadoop. Now let us consider what happens if a single data node fails. Okay. So consider that we have stored our data in data node 2, data node 5, data node 7, and data node 10. We are processing the data. In the middle of processing, one data node gets failed. That is data node 10 gets failed. If data node 10 gets failed, all the data present in that node will get lost. So to avoid this situation, to avoid such loss, copies of the data blocks of data node is stored on multiple data nodes. So this is called as data replication. Usually we will maintain this data replication using a factor called replication factor. So replication factor, default value of replication factor is 3. It means that for each block of data, 3 copies of data will be maintained. 3 copies of the same data will be maintained on different data nodes. The position where the copies are maintained is usually we will maintain 2 copies in the same rack. So this is, for example, this is like rack means, so we are having different racks, right? So we will usually maintain 2 copies of data in the same rack and 1 copy in a separate rack. Because if this complete rack gets failed, we need to fetch the data, right? So usually this is the process of storing the copies of the data. It will store it in the same rack, 2 copies, and 1 copy will be stored in the different rack. Now let us come to our scenario. That is our data node 10 has get failed. So how to maintain this? So if this data node gets failed means, if this node gets failed means the replication factor is equal to 2 now. Actually we need to maintain the replication factor equal to 3. Now the replication factor has got to 2. So immediately name node what it will do means it will try to find out where the next copy of the data is stored.
நீ மட்டும் எக்ஸாம் சொன்ன பார்த்ததுல அது மாதிரிதான். ஆமா புக்க எடுத்து வச்சு டைஜஸ்ட ஓபன் பண்ணி பேசி பார்த்தது 2 கண்ணால பார்த்தேன்.
I think someone is.
Ma'am, one second.
நாங்க படிக்கலாம் இருந்தா பார்க்காம.
Participants kindly mute your mic. Devi Priya, can you please mute your mic? Okay, thank you. Ma'am, you can continue now.
Okay, ma'am. So the replication factor turns to 2 now. So immediately what name node will do means it will try to check where the other copies are located. So as I told before, 2 copies will be stored in the same rack. So if these nodes or if these data nodes are present in the same rack, then a copy of the data will be available in data node 11, isn't it? So immediately what a name node will do means name node will find out where the copy is stored, and 1 copy of the data is copied to another node, another data node. Okay, so from DN11 data node 11, actually we are having a copy of the data. So that copy of the data is immediately transferred to the data node 12. Why we are doing this means in order to maintain our replication factor we are doing this. So after copying, now our replication factor is equal to 3. Okay, when the data node 10 gets failed, our replication factor will get reduced to 2 because 1 node gets failed, so there is no data there. So the replication factor is reduced to 2. So we need to maintain the replication factor. So in order to maintain it, immediately name node will check where a copy is there and it copy the data from that data node to the nearby data node. So from data node 11, the nearby data node is data node 12 only. So it copies from data node 11 to data node 12. So that the replication factor is maintained. So always name node will try to maintain the replication factor, and once, for example, it may be due to some network failure or any connection may get loosed. So if the data node 10 uh, comes again means what now becomes the replication factor have now becomes 3. Sorry, the replication factor now becomes 4 because the data node 10 has come back. So what in order to maintain the replication factor again, what what name node will do means name node will erase a copy in any data node. Okay, it will erase it and it will maintain the replication factor. So usually in order to avoid failure we are going with replication, and for maintaining maintaining the copy we are making replication depending upon some replication factor, and throughout our processing we try to maintain that replication factor. Okay, so this is the concept over here. So this is the strategy of replication. I have explained it. So in our Hadoop architecture, I have explained about how data is splitted using HDFS layer. Then MapReduce layer is meant for processing, data processing. In MapReduce, we are having two types of phases like map phase and reduce phase. So map phase, what it will do means it will take a set of data and convert it into another set of data. Okay, so that is the process done in map phase. Let me show the diagram. So for example, if an input is like this, bus, car, train, plane, car, like this is an input. In mapping phase, what we will do means it will take the set of data and convert it into another set of data. Okay, where individual elements are broken down into tuples. We are splitting the individual elements into tuples. Tuples here, it involves key and value pass. See, bus. So we are splitting this into three blocks. One block containing bus, car, train. Another block containing train, plane, car. Another one bus, plane. Now what map phase will do means map phase will convert that into a key value pair. So bus is occurring only one time, car is occurring only one time, train is occurring only one time. Similarly, in this block of data also, this processing of conversion into key value pass is done. And in this processing also conversion, here bus is occurring 2 times and plane is occurring 1 time. So this is the output of our mapping phase. Okay, this output is a intermediate output. Okay, then after intermediate output, this intermediate outputs are processed in parallel on different clusters. On different clusters we are processing this inputs. So in order to group them, what we will go means we will go for reduce phase. Okay, in reduce phase also the similar key data should be on the same cluster. So reduce phase is nothing but we will try to combine all the key value pass. According to the key we will try to combine. Okay, so here after combining we have find that bus is 1 and here bus is 2. So buses are combined. Then in train all the total number of trains are combined, and car all the total number of cars are combined, and plane all the total number of planes are combined. So this is done where means this is done in intermediate phase. Okay, then in reducing phase what it will do means it will just find out the key value pass and it will reduce to an output. So here we are having bus 2 and bus 1, so it is reduced to bus in total 3. And here we are having car 1 and car 1, and it is reduced to car in total 2. Okay, and train, here we are having train 1 and train 1, and here we are reducing into train to 2. Plane 1 and plane 2 we are reducing to plane to 2. So this is how reducer phase will works. Okay, so then the final output is this, it will combine the output from different blocks, and this is the combination output, final combination output. So this is the workflow of our a simple word count program. Okay, so mapper what it will do means mapper reads the data in the form of key value pass and it outputs 0 or more key value pass. Key is nothing but the byte offset. Key is nothing but the byte offset into the file at which the file starts, the byte offset. Then value is nothing but the contents of the file itself. The reducer phase, what will do means after the map phase is over, all the intermediate values for a given intermediate key will be combined together. The list will be given to the reducer. So the intermediate results that is given to the reducer will be analyzed and it will provide a result in the form of key value, final key value pass. And this output is returned to our HDFS, Hadoop Distributed File System. So this is how Hadoop works. So as a summary, so we need to understand about in Hadoop, two things are there, HDFS and MapReduce. HDFS stands for Hadoop Distributed File System. And I have explained how a file will be maintained or will be stored in a Hadoop distributed file node. Then master slave architecture will be there. In master node, three types of nodes are there, name node, secondary name node, and job trackers will be there. And in slave architecture, we are having data nodes and task tracker. So name nodes is like a master. It will handle all metadata information, and job tracker is like a scheduler. It will schedule and give the jobs. And actual processing is done in the data nodes, and task tracker is used for supervising the data nodes. It will supervise the data nodes and send the information to its master job tracker. Okay. Then the actual processing in Hadoop is mapping process. Then in intermediate processing, we are having sorting and shuffling phase. Then finally a reducing phase. So this is the overall architecture of Hadoop. Next, let me show how to install and run Hadoop in our Windows. Usually we need to install and run Hadoop in Linux operating system only. If we are not having a standalone alongside a Linux operating system, means we can also work with Windows operating system. But I usually recommend to work Hadoop with Linux operating system only. Okay. So first, I will share this PPT to you all so that you can work and see or install and see the Hadoop in Windows. Okay. So first, we need to download Java. We need a Java in our Windows. So let us download the latest version of Java from this website, oracle.com. It will require a sign in. You just create an account and you just download this last one, JDK 82241. Okay, after downloading it, it will give a pop-up window like this. You just click download. It will get downloaded. Okay. Then after downloading Java, we need to download Hadoop. You can download Hadoop in apache.org site. So here you need to always go with the latest version that is released. So I'm just downloading the stable version 3.1.3. You always don't try to download any software, the latest software. Okay, you try to download the previous software, that is a stable software you try to download, because the latest software will go with updates and all the latest software. So always prefer of downloading a stable version. Okay, so keeping that in mind, I'm just downloading 3.1.3. that is this. You just click on binary. It will forward you to this Apache site, and here you download Hadoop 3.1.3 tar.gz version. So if you download it, a zip file will be downloaded. Okay. Now these are the two files that is downloaded. You just move your downloaded files into your C drive. You just move it. Then you start installing Java. Though your system has installed Java, you once again try installing Java. Okay. While installing Java, it will ask to change the destination folder. So where you can change your destination folder, you just click change and you create a folder in our window, in your C drive in the name Java. You create a folder in C drive in the name Java and you start installing. Okay. After installing it, already you have installed Java in your system, means there will be a folder in the name Java in your program files. So what you need to do means you simply explore your C drive program files and search where Java folder is present. So inside Java folder, there will be some JDK packages, something will be there. Whatever will be there, you just copy it and paste it in the Java folder that you have created while installing Java. So while installing Java, you have created a Java folder in the C drive, right? So just copy the contents and you delete the already installed Java file in order to avoid confusion. Okay. Once again, I will repeat. While installing, create a folder in the C drive in the name Java. After successfully getting installed, already you might have installed Java, and that Java folder will be available in program files. Go and search that Java folder and explore the Java folder. In the Java folder, there will be some contents. If there is some content, means you simply copy the contents and paste it in the newly created Java folder, and simply delete the Java folder that is available in your program files. Why we are doing this means two Java folders will be there and there occurs a confusion. That's why we are deleting one Java folder. If you are freshly installing Java in your system, means you might not find any Java folder in your program files. Then this processing is not needed for you. Okay. If Java is already installed in your system, you have to follow this step. Next. Okay. Next step is you need to set environmental variables. I think most of you know how to set the environmental variables. If you don't know, let me explain once again. In the control panel, you are having, and you just type environmental variables. Environmental variables will be available. So there in advanced tab, you click environmental variables. Then here two boxes will be there, user variables and path something system variables will be there. Under user variables, you click new and you give variable name as Java and variable value as you need to give the path. You just move on to your Java folder and you move up to the bin and you copy the path and give the path over here and click OK. Then under system variables, here if you scroll down, you have a path. There will be a path folder. You click on that path and you click new. Okay, and then a new box will get opened. There you do the same thing. You just give the same path and click OK. So now the environmental variables has set successfully. Okay, one thing you need to give in the user variable. Then here you have to select the path and you have to click new and you have to paste the new path there. That is this Java bin path there, and you have to click OK. Now the environmental variables has set correctly. In order to check whether your Java is installed correctly or not, simply open your command prompt in your administrator mode and you give Java C or Java -version. It will display the version of your Java file. Then it means that Java has been installed successfully. Now coming back to our Hadoop. Okay. So the Hadoop file will be downloaded in the form of a zip file. Okay. You need to extract the zip file into your C drive. You extract in the form of a folder. Then you explore in the folder Hadoop. Inside Hadoop, a folder in the name etc will be there, etc. etc will be there. Under etc, a Hadoop folder will be there. Then in that folder, lot of files will be there like this. So you need to configure some changes in the files. Okay. So first file you need to configure is core site.xml. See here under Hadoop we are having, you just search and take core site.xml. See here there is a file XML document, right? Core site.xml. You just open with Notepad and you just type this configuration file. Okay. There will be configuration. Inside the configuration, you just give the property, that is name is equal to fs.default fs and localhost is equal to localhost 9000 property, and you close the property. Then you save the core site XML. Okay. Next you open mapped site.xml and you type this properties. Okay. Then you save mapped site.xml. Then you open yarn site.xml and you type and you paste the properties there. Okay. You can type save the properties in the between the configurations. Okay, then you save yarnsite.xml and close it. Then after that, inside the Hadoop folder, you create two folders. Sorry, you create a folder in the name data. Okay, inside the data folder, you create two new folders in the name data node and name node. After creating data node folder and name node folder, you just copy the path of the data node folder and name node folder. Okay, just copy the path. Then you need to edit hdfs site.xml. Okay, in hdfs site.xml, you just copy this property, and here there is a name node, right? So here you have to paste where your name node folder is available. That path you need to paste. And in data node, you need to paste where your data node is available. Okay. So this is with hdfs site.xml. So here you have to give the path where your name node presents, and here you have to give the path where data node presents. So these two are nothing but the folders that you have created now. You have created a folder data, and inside the folder data you have created two folders, name node and data node. That's what we have given over here. That's all. You save the hdfs site.xml. Now another folder, hadoop env.cmd. You just open this folder, and you need to, and you just explore in that file. You have a line like set java home. In that line, you need to give your path of your java, which path you are having for your java. That path you need to provide here. That's all. You save hadoop env.command file also. So totally how many files we are editing? Core site.xml, mapred site.xml, yarn site.xml, then hdfs site.xml, hadoop env.cmd. After editing all these files, now you need to set environmental variables for your Hadoop also. Okay, you just copy, you just explore the folders Hadoop to bin, you just copy the path, and as like we said for Java, you need to set environmental variables for your Hadoop also. You give the variable name as Hadoop name and give the path and click OK. And here under system variables, you click the path and you give and click new, and you give the path for your Hadoop. Okay, then see like this, you have to give the path for your Hadoop. That's all. So these are the preliminary, after setting the environmental files, these are the preliminary steps you need to do. I have a folder here. So this folder will have the necessary configuration for bin folder. So you can download the files from this drive. So this will download a Hadoop configuration zip file. You just extract the zip file, and in that zip file there is a file called bin. There will be a bin folder. You just copy the bin folder, and you just go and paste into your Hadoop bin folder. Okay, in Hadoop there is bin folder already. You just delete the bin folder, and you just copy and go the bin folder from this extracted file. Okay, you just copy the bin folder from the extracted file and go and paste it in the Hadoop. Okay, now you just remove the unwanted files. So these are the preliminary steps. After doing all these steps, you go to command prompt and run it as an administrative mode, and you can type hdfs name node hyphen format. Now the name node will start executing. Now the name node will start. Okay, you know what is mean by name node? Name node is our master node. Master node will start. Then after that, you open another command prompt as an administrative mode, and you move to the Hadoop sbin location. I think you can move, you know how to move to the Hadoop sbin location. So you just move to there, and you type start all-all.cmd. So this start -all.cmd will open all the demos related to your Hadoop, that is your resource manager, node manager, data node, name node, everything will be opened. Okay. Now, in order to verify your console is working properly, just go to some browser and you type localhost 9870. If you type localhost 9870 means it will just show, it will give you a window there. It shows HDFS is working. Likewise, it will show a message. It means that your Hadoop is working properly. Okay. In order to start yarn, you need to give start yarn.sh. So this will start the yarn. In order to check whether yarn is working properly, you just type localhost 8080. So this also will open a yarn console and it shows yarn is working as properly. Okay, so if you get if you get the messages in your local host, then it means that Hadoop is installed correctly. This is how you have to install Hadoop in your Windows file system. Okay. I think ma'am.
Thank you, ma'am. Participants, if you have any queries, you can type it in the chat box. Ma'am, that's a wonderful session, ma'am. Thanks for sharing your knowledge on this particular topic with demo, ma'am.
Thank you, ma'am. Thank you. Thank you, LLR College, for giving me this wonderful opportunity. Thank you all. Thank you all for the participants for listening to my session with patience. Thank you all. I will share the PPT to you all so that you can get a knowledge of how to install and work with Hadoop in Windows file system. Thank you all. Thank you.
Yeah, ma'am. Thank you. Thank you
Thank
so
you,
much
ma'am.
for the session,
Thank you,
ma'am.
ma'am. Thank you, ma'am. Can I leave, ma'am?
Yeah, ma'am. You can leave
Okay,
now.
ma'am. Thank you, ma'am.
So participants, the feedback, for your information, the feedback link will be provided on the end of the FTTP. You will be getting attendance links alone for a day. So you can, participants, you can leave for lunch now and please be back at 1:30.